appears to be a 3D perspective to it. It appears to go off in depth. There appear to be cross lines coming down like that, and it appears to be very, very, very eaten away. The most resilient remaining object appears to be this funny looking thing with this tail standing next to this shard sticking up on a surface that should have neither. Now, as we got better at the processing, as we began to really fine-tune the details of exposure and grayscale and gamma and all these tricks you can play with images, we developed some pretty interesting images, and you can now see that this light to dark to light is an artifact of the processing. It really should be light all the way down to the surface. Okay? You'll see this in every process NASA image. It's standard for this kind of technology. But what's interesting is that this thing appears to have a 3D structure. You can see that there's alignment here, there's one here, and there's one here. It's almost like this thing was on a tripod. And then as you get near the top, there appears to be more alignments. There appears to be a central core, and up at the top there appears to be now very interesting internal geometry. Remember, we're dealing with an absolutely airless vacuum. There is nothing in space above the moon. You're looking at something that is at a minimum 250 miles away if it's at the horizon. And at that distance, if you do the proper calculation, this thing is standing up against the sky something like 5 or 6 miles above the moon. And it has geometry. When you play games with color, what you see is that there is a very interesting depth, an optical depth. The inner parts, which are the brightest, red is bright, yellow is less bright, greenish is less, violet and maroon is even less. In other words, the density of color, the brightness of color, the color of the color corresponds to a brightness of the light bouncing around in this thing. The brightest parts are not on the surface as you would expect if this was a piece of rock. They're inside. This is very consistent with the idea that we're looking at some kind of crystalline object, some kind of glass-like object, which, like a diamond, is trapping light inside and is brightest where the material is optically most dense and has the most reflective planes. Now that's interesting because that turns out to be the inner parts. Well, thinking of these planes as meteor bumpers or meteor shields, if this is a real structure, and if it has been eroded and eroded and eroded by constant meteoric bombardment over billions of years, then that's exactly what you would expect. Tall cubical structures extending 5 to 7 miles above the moon's surface, composed of some glass-like, highly reflective, highly scattering, highly light absorbent material, literally has no place on the moon. The moon as we were given. Now, for those who are going to say, aha, but you've only got this on one picture, Hoagland, it's probably just a defect. Hold on. This is now a close-up. This has been produced or processed by a new technique, a new image processing technique called fractal processing. I will not describe fractal processing, but it is literally the latest state of the art. It has been adopted by the U.S. Army for all their image processing. We are in discussion with the company that provided them with their software. They provided us with our software. If the Army trusts what they're seeing on their pictures, why should we not trust what we're seeing on our pictures? You see the logic here? Anyway, here we have a really remarkable object. I hope you understand how phenomenal and anomalous and bizarre and wondrous and magnificent and any other adjectives I can come up with this thing is. This should not exist. This is a megacube roughly a mile across, composed of smaller cubes which have been beaten to death by meteors. You can see lineal planes and fractures. You can see transparent material veiling other material. You can see that this is part of a larger structure with little bits of glass or something scattering light in a geometric pattern. You can see internal consistency. In other words, you're seeing something that by everything we think we know should not be there. But it is. And the closer you get, the more the detail you can extract. Now we think that the ultimate resolution is just about reached here, although we could probably go another factor of 2 if we had enlarged the prints by a significant size change that we were unable to do simply because of physical processes in the focal length of the lens that was being used. But what we're seeing is a multiple scattering surface with light coming in, bouncing around. The sun, by the way, is almost directly behind the camera. This is direct bounce back, and I'm going to have a slide here momentarily to show you what we're talking about when we talk about multiple scattering, because the geometry of how light moves between the sun, the surface, and the camera in each of the technologies that we're using is very important to figuring this out. So, have I bored you with enough photographs of the cube sitting on top of the tower? All right, this is the final one. This now is the color of the fractal. You can see that there is geometry within geometry within geometry. There are planes in here reflecting light, scattering light. They are apparently very well preserved, as you would expect if they were in the middle of a structure which has protected them from meteor bombardment because they're at the center. This thing must have been much larger, and it must have been whittled away by erosion and erosion and erosion. And on the moon, the only erosive process is that incessant meteoric rain, hypervelocity impacts. Now, what in the world, geologically, could cause a structure like this to be raised 5 to 7 miles above the moon and then persist for billions of years against this incessant bombardment? Is it conceivable that the moon that we think that we know, this moon, the moon of gently sculptured hills, the moon that was very carefully shown to us by NASA on television, and in the handful of pictures that have been released out of the literally millions of pictures taken of the moon, when was the last time you saw a new lunar picture? If you look at the textbooks, they keep recycling the same half-dozen frames. And they've literally got millions of pictures. Doesn't anybody wonder why we haven't seen a lot of pictures? Is it because the moon is all like this, dull and boring? Or is it because on some of those pictures, if you were to look in the corners or at the top, you'd see something like this? Obviously, the big question everybody wants to know is, well, what have you got in the way of corroborative evidence? Is this just a fluke of the picture? Is it just a spurious, something or other? Is it a dust speck, which you've enlarged, beyond all reasonable expectation? Or is it real? So to answer the question, what we're going to do now is we're going to go to the Apollo 10 series of photographs taken of the Okhotsk region in May of 1969, literally 25 years ago tonight, practically, within a few days. It's actually last week. But pretend I was here last week. A quarter of a century. And this is a map that is published in a very voluminous catalog that was issued by NASA, by the Manned Spacecraft Center in 1971 on the mission. We'll get back to the catalog in a minute because we found some other interesting things about that catalog. What I've done here is I've highlighted 3 frames, 4854, 4855, and 4856 that I'm going to show you. But before we do that, let me show you this. This is a brief geometry of the lighting by which we're going to analyze these. Physicists, when they look at a surface, are concerned with how the light is reflected from the surface back to the observer. You can have what's called backscatter, where the light basically comes right back in line with the light that hits the surface. You can have normal lighting, meaning at right angles, more or less, or you can have forward scatter, all right? Now, when you look at surfaces, and there's a familiar